An online store sounds simple until you look behind the checkout button. A customer clicks buy, and suddenly the checkout service starts making request after request. Inventory, shipping, billing, analytics, email. Every order becomes a chain of direct service calls. At first, this feels completely reasonable. Small systems often work this way. But as the company grows, the architecture starts mutating into a dependency spiderweb. Recommendation systems get added, fraud detection appears, warehouse tracking, customer notifications. Every new feature creates another connection, another timeout, another thing that can fail. Now, imagine the shipping service crashes for an hour. Orders are still arriving, customers are still paying, but checkout cannot deliver shipping requests anymore. So what happens to those orders? Maybe engineers built retries. Maybe they added temporary storage. Maybe they accidentally created duplicate shipments during recovery. Without careful infrastructure, some orders can simply disappear. That exact operational pain is why Apache Kafka became so important. Kafka changes the communication model completely. Instead of services directly calling each other for every step, services publish events into a shared log. An event is just a tiny fact saying something happened. Order 42 was placed. Payment succeeded. User signed up. So now, checkout receives an order, writes an order placed event into Kafka, and immediately moves on. It does not wait for shipping or analytics or email. Other services read the event independently whenever they are ready. The writers are called producers, the readers are called consumers. And the important part is that producers and consumers do not need to know each other exists. That decoupling is the breakthrough. Inside Kafka, events are organized into streams called topics. You might have an orders topic, a payments topic, and a shipments topic. A topic behaves like an append-only journal. New events are always added at the end. Every event gets a position number called an offset. Think of offsets like line numbers in a giant notebook. Order 42 might live at offset 1053 inside the orders topic. Now, here's the idea that surprises most beginners. Reading an event does not remove it. Kafka is not a mailbox where messages vanish after someone opens them. It is a durable log that remembers. Shipping can read Order 42. Billing can read Order 42. Analytics can read Order 42. The event stays there the entire time. That persistence is what makes downtime survivable. Suppose shipping processed events through offset 1052 before crashing. While shipping is offline, Kafka keeps storing new orders. Checkout keeps producing events, nothing blocks. When shipping comes back online, it resumes from offset 1053 exactly where it stopped. No lost orders, no giant replay script. The log itself becomes the recovery system. Every consumer tracks its own reading position independently. A slow consumer never blocks a fast producer. But what happens when millions of orders arrive every minute? Kafka scales by splitting topics into partitions. You can picture partitions as parallel lanes on a highway. Different partitions live across multiple servers called brokers, allowing many producers and consumers to work simultaneously. This parallelism is why Kafka powers systems at companies like LinkedIn and Netflix and Uber. Payment pipelines, ride tracking, fraud detection, and massive analytics systems all rely on the same core idea. Write events once into a durable shared log and let many systems consume them independently. There is one important trade-off, though. Kafka guarantees ordering only inside a single partition. If all orders for Order 42 go to the same partition, they stay perfectly ordered. Across multiple partitions, total ordering disappears. And despite the hype, small applications often do not need Kafka. If your app handles a few messages per day, direct calls might be simpler. Kafka shines when event volume is huge and losing data is unacceptable. So the big picture is simple. Producers write events into topics. Topics are durable logs. Consumers track their own offsets and read independently. Nothing disappears when a service goes down. That is Apache Kafka, the central nervous system of modern software. Next time, we open up partitions and consumer groups to see exactly how Kafka scales without breaking a sweat.